Alright, now we're going to look at the periodic table and how that coincides with electron configuration notation. And you should have looked at this in the worksheet that said quantum model continued. So this should be your review. Alright, so let's take, for example, that nitrogen that we just had. So we're going to look here at nitrogen. Okay, it is in group 15, period 2. Okay, remember periods are rows, groups are vertically, columns. Okay, and nitrogen has 7 electrons because it has 7 protons. Protons and electrons are equal. This is a neutral atom. So we think of our periodic table as a road map. A road map that always starts up here in the upper left with hydrogen. Okay, and the first 2 groups there are considered our S block. Okay, so the 2 columns in red there are considered our S block. And we call it the S block because any element that is in there will end in an S. And when we looked at S's before, we noticed that their energy level numbers will be the same as whatever period or row they are in. Okay, so hydrogen is a 1s1. It's in the first row. Okay, it's in the S block. It only has 1 electron, and it's in the first group. So 1s1. Okay. Now, helium is actually also part of the S block. Okay, hydrogen and helium can be kind of goofy sometimes. This is why this periodic table has it written on in both places. All right, helium is actually part of the S block because remember, S's have that line, and a 1s, and I have 2 arrows in it, an up and a down. So the hydrogen would be 1s1 with an up arrow. Helium would be 1s2 with 2 arrows. Okay. Lithium then would end as a 2s1 because I need 3 electrons. The next thing we fill is a 2s orbital. So you don't have to memorize the order. You just have to know that this is the S block here. All right, and that anything in these 2 groups is going to end in S. If it's in the first group, it ends in something S1. If it's in the second group, it ends in something S2. All right, and the S's go right along with the period numbers. So this is 2s, this is 3s, 4s, 5s, 6s, 7s. Okay. Now, if you put in there as well nitrogen, okay, because I haven't gotten to nitrogen yet, and that's where I want to get. And we said before that nitrogen should end as a 2p3. Okay? So that means that this entire block here in green is the p block. Okay? That means that anything that ends in this block here will end in a p orbital. Okay, so nitrogen we said was 2p3. Well, that makes sense. It's in the second row, so 2p, and it's the third one in. So 2p1 would be boron, that's how that would end. Carbon would end into 2p2, nitrogen would end into 2p3. So the map part here goes, okay, well I go through both S's, so there's 1s2. I go through both of these S's, so that's 2s2. And then I go to 2p, 1, 2, 3. So nitrogen is 1s2, 2s2, 2p3, just like we saw before. Now if we take scandium, which is the other one we looked at, and we know how that one should end, okay, and scandium is right down here, we haven't gotten to that block yet. So if this is the S block, this is the P, the shape we haven't talked about yet is the D. So these transition metals in the middle are all part of the D block. So if an element ends in the middle here, it ends in something with a D. Okay? Now these D's are the ones that get a little bit crazy and are 1 level off of their row number. So if we're going to scandium, I go through both of these S's, so 1s1. I go through both of these S's, so 2s2. All of these P's, I'm not yet to scandium, is 2p6. Not to scandium yet, so I go through both of these 3s's, so 3s2. All of these p's, 3p6. all of these 4s's, so 4s2, and there I am to scandium. And I know from before that it should be 3d1. Well, look, in the first group here, so that's 1. But these are 1 level off. Those are the 3 Ds with scandium. So S's and P's are the same number, energy level-wise, as the row number. D's energy level numbers are 1 less than their row number. So scandium starts the 3 Ds, and I go all the way to 3D10 if I go to zinc. Then we have yttrium, which is going to be a 4D and across. Lanthanum is a 5D. Actinium is a 6D. Okay, these are the D block. All right. There are a couple of exceptions with the D block, and I'll just mention them here. And I don't believe I mentioned them earlier. Okay. The row here was chromium, and the row here was zinc. Okay, if I was going to do the electric configuration for chromium, all right, so I start at the beginning. I go through both S's for hydrogen and helium, 1s2. Then I go 2s2, 2p6, 3s2, 3p6, 4s2, and then I should go 3d, 1, 2, 3, 4. So I should have 4s2, 3d4 as the end. What actually happens in real life with anything in this row here, okay, is that one of these electrons, part of the S, actually bumps itself up and evens out that D. Because as we looked at before, D's have 5 little lines. So what happens is one of these guys in red bumps itself up to make this nice and even so that I'll have 4s1, 3d5. Still the same total number. One just bumped up, and it's actually more stable to be a half full than one of these full and this one not. It's just one of those crazy exceptions. Okay, if I would ask you on a test, it would be extra credit. The same thing here works with zinc. Zinc should be 4s2, 3d9. Well, what happens is this one of the 4s's bumps itself up, and it's actually 4s1, 3d10. Because a full level is more stable than an almost full one. So there's 2 little columns there in the D block that are even more confusing at times, that have their own. So those are the 2 columns in the D block that have their own exceptions to everything else in the periodic table. Okay, well, the last group we haven't looked at yet would be the F block, and this is the block down here at the bottom. Okay, and I like the way this periodic table is organized because it has the actual 14 down at the bottom. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. Okay, F blocks, F's are 7 lines. Okay, so there are 14 total electrons that can go in an F block. All right, now as we looked at before, okay, D's are 1 level off, F's are 2. So cerium goes right here after lanthanum. Okay, so cerium is a little bit confusing. Okay, it would actually be in the 6th row, which actually then makes it a 4F. It's 2 lower than what it should be. Okay, so things in the F block, like I'm going to look at cerium here as an example with 58 electrons. Okay, I would probably use noble gas notation. And remember, with noble gas notation, we take the previous noble gas and we put those in brackets because that'll represent everything before it. And I don't have to sit here and go 1s2, 2s2, 2p6. Gets a little old, gets a little long. So I looked at the previous noble gas here, and the previous noble gas is xenon. So what I would do for cerium is I would put xenon in parentheses, and then I would say, okay, what's coming next? Well, I'm in the S block, okay, and I'm in 6, so 6s2. Then I go to lanthanum, which is now a D block, and it's 1 less, so 5d, 1. And then I jump down here and go to 58, which is cerium, and I go 4f1. So F blocks can be a little more confusing because they're going to have one D and then however many F's if you end up in the F block for either one of these. It's just how the periodic table is organized, okay? One of those crazy things about it. So remember the period number and your level number are the same in S's and P's, okay? One less in D and two less in F, okay? So remember the different blocks in the periodic table, and you can use your periodic table as a map, and you don't have to remember what goes in what order, okay? So that should be a review of electron configurations, orbital diagrams, and then I touched on the noble gas notation right here at the end. Okay, so there's your review of all of the electrons and quantum models and configurations.